paper and try to reduce those mistakes, right? Okay, so what is, yes, thank you, Shaima, right? So prime numbers, right? Divisible by one and itself. So what are the examples? The example is 2, 3, 5, 7, 11, and so on. So these numbers are prime numbers. So the smallest one is what? Smallest prime number is 2. And then we have co-prime numbers. So in co-prime numbers, they are a pair of numbers. Pair of numbers which have only one, and one is the number, right? One form. So this definition is very important in the irrational numbers. So that is why this is very important, right? So let's say we have 6 and 5. Are they co-prime? Yes.
Yes, sir.
Yeah. So Aisha and Shaima, what about you guys? Are they co-prime?
Yes, sir.
Right. Yes. So they are co-prime numbers because the common number between them is 1. 1 is only common in 6 and 5. Remember, the 6 is not a prime number, right? But when we take the pair, so in pair, this is a co-prime. 1 is only common. So the this one is this is co-prime numbers, and then we have composite numbers. So composite numbers are those numbers, so which can be represented as prime factors, right? So for example, 4. So 4 I can write 2 into 2. So this is factor of 2, right? And let's say 6. So this is 2 into 3. So any number which can be represented as the product of prime factors, so that is composite number. So the smallest one is what? Smallest one is so these are the things, and then we have prime factorization, right? So we have prime factorization, and using prime factorization, what we calculate? So HCF and LCF using prime factorization. So for the case of, let's say, LCF, LCM is highest common power and rest of this is LCM, and HCF is what? This is lowest common power and nothing else. So these are LCM and HCF. And there is, let's say we have one number, which is 2 square, 3 cube, 5 square, 7, 11. We have another number, which is, let's say, 2 cube, 3 square, and 5 square, and 7. So then what would be the LCM of these two numbers? LCM would be how much?
2 cube into 3 cubes into 5 square into 7
5
into
square
11.
Wood and HCF would be, yes, HCF would be
2 square into 3 square into 5 square, 27.
good. So yes, absolutely correct. So these are the LCM and HCF. So one important relation about LCM and HCF is that LCM of two numbers and product of LCM and LCM of two numbers, that would be equal to the product of the two. These are the things that we understood in this chapter. And the last thing that we did in this chapter was irrational numbers. Irrational numbers, and in this part, we understood about proving, let's say, root 3 as irrational number. Right. So this is the thing that we did. And how did we do that? So we did this by reductio ad absurdum, right? And yeah, commonly, what is it called? Yeah, what is it called? What is it called? So this is called reductio ad absurdum method. But commonly, it is called what is it? It is called
Contradiction method.
contradiction method. Yeah, this contradiction. Yeah, this word is the one technical term is I am forgetting. Right, contradiction method. We can say right. So in this method, what we assume that we assume the opposite thing, and then we prove that our statement or our assumption is wrong, right? So this is the thing that we do. I have got it. That. Yeah. So this is what we do, right? And this is all about the first chapter, right, guys? This
Yes,
is
sir.
quickly note it down, guys. Right? You guys have already remembered these things because you have revised this so many times, but I want you to quickly note it, right? So that you guys can remember it again. And then we'll do two questions, and then we will move on to. Okay, so in this week, what was the exam? The exam was on application of trigonometry, and circles, right? This week exam was about that, right, guys?
So
Yes,
instead of
yes.
circles, it was not circles. It was coordinate geometry.
Oh, coordinate geometry. Yeah. Coordinate geometry, trigonometry, and application. So a one person asked this question that can we get the fraction in negative numbers? So who was that? Yes, who asked this question? Anybody asked this question that can the ratio be negative? Did anybody ask that question? So none of you asked that, right? Because there was this question. So there was one line, and then they were. Yeah, whenever you guys have noted it down, then I will discuss that question, right? That I can do.
No, it's
Noted. Okay, so then, yeah, this part you guys already know, but yeah, whenever you write it many a times, then this.
Can you scroll up?
Oh, so you have not.
Thank you, sir.
Okay. So, and now you guys, right, buckle up and just focus onto the exams, right? Because today is 21st January and then February is coming, right? Whenever you guys have noted it down,
Noted, sir.
noted everyone. Everyone, Shaima and Aisha, what about you guys? Noted.
Yes, sir.
Okay,
Done,
the
sir.
yeah, what question I was talking about? Let's see if I have that question paper or not. Question was the question was from quadratic equation, right? I'm doing this. I have that. Okay, I don't have documents. Question was like this. Let me just tell you guys the question. So we are going out of right out of context this question we are doing, but let me just talk about this question. This was a very good question. So the question was like that find the ratio, find the ratio in which the line x minus y minus 2 equals to 0 divides the line segment. Yeah, this is supposed to be a coordinate geometry question, but I'm writing it in here because I just remember. Right. So somebody was asking about let's say P and Q, which is 8 comma 9. So what would be the idea? Right. So whenever these 2 points are given, right? Whenever these 2 points are given, we can directly calculate what? Yes, who is going to narrate me the idea? What the ideas that we are going to follow?
We can let the ratio in which the line divides as C.
So first you have to find the coordinates x and y, which divides the line.
Yeah.
And then substitute the value in the equation and find it out.
Good. So everybody understood what Aisha is saying?
Yes, sir.
Yeah. So the first step that we take is that assume ratio is case 2. This is first step. Then we find out the coordinates x and y, and then third we put this value in this line. So these are the 3 steps that we have to follow. right? Okay, we are going out of the constant because we have to 1 to 4 chapter. But yeah, this question came in my mind. So please quickly do this question and tell me what would be the answer. Because first chapter is not that long, so we can take the liberty, right? Then we'll talk about the second chapter. Kind of questions we have done, right? Hmm. Guys, did you guys get the answer? So whenever some complicated
Sir,
question,
I
yes,
got 2:3.
2:3, right? So Aisha got 2:3. So Aisha has got this is 2, this is right. Yes, Shaima and Amira, what about you guys? Yeah, I can understand we are going totally out of the context because we are doing this first 2 4 chapters. Hmm. Yeah, and Shaima. Okay, let me just do this problem quickly and then you guys check. So first, this is the step that we have to follow. So ratio is k is to 1. Right, now we have this ratio, then we can figure out this coordinate x comma y. So what would be x? X is mx2 plus nx1 divided by m plus n. So we don't have to be afraid of so many numbers, right? So m is k and x2 is 8. So 8k plus n is 1 and x1, so 3 divided by k plus n. So this is our x coordinate, right? So x is whatever this coordinate is, and y would be what? Y would be my2 plus ny1 divided by m plus n. So m is k and y2 is 9. So 9k and then 1 into minus 1. So minus 1 k plus 1. So we have got x and y. We can put this value in this equation, right? Because this line is passing through this point. So this will have this solution, right? So if we write it in here, so 8k plus 3 by k plus 1 minus 9k minus 1 by k plus 1. And let us write it as 2. Right, we take this 2 in the other side. So remember, this is very important to write this as bracket. Right, so this is very crucial. Otherwise, you will get a negative term and then we get the wrong answer. So 8k plus 3 minus 9k plus 1 and 2k plus 1. So what is this thing? So this is 8k minus 9k minus k plus 4k plus so this will come in here and this will go the other side. So what will get? 3k minus 2. So k is 2 by 3. So m is 2, n is 3. Yes, Shaima and Amira, where did you guys get stuck? Yes, Amira and Shaima, where did you guys get stuck? Or did you get the answer? Yes, guys.
Sir, I did the last step, minus k plus 4, 8k plus 3, 8. I just did a silly mistake, so I got the
Yeah,
answer.
this one. Yeah, this one. Yeah. So please careful. Be careful with these minus and plus signs, right? They can cost you the whole question. They can cost you maybe 3 or 5 marks, right? Okay, is it clear, everyone? So now let us get back to what we were doing, right? Do you guys want to note it down? Yes, you guys want to note it down.
Yes, sir.
Note it. Yes. Let us, because the concept of the first chapter is done. So now we will pick only a few questions because we have to cover 4 chapters in one. So let us pick. We'll pick some. Let's say, okay, I have already done this in here, right? I guess we can also start the second chapter, polynomials, right? That we can also do. But let's say for starters, let us start with very simple question. You guys tell me that what is the divisibility of 2 and 3? What is the divisibility of 2? Yes, because in these in the first chapter we have to remember first divisibility rules, right? So that helps a lot. What is the divisibility of 2? Yes, Amira, what is the divisibility of 2? How can we check without dividing that the number is divisible by 2?
Any number with the last digit 0, 2, 4, 6,
Yeah,
or
good,
8 will be divisible by 2.
good. So if any number whose last digit is divisible by 2, whose last digit is even number, right? So that is called that will be divisible by 2. And what about the divisibility of 3? How can we check that?
So when we add the sum of the digits, it should be
Yeah.
divisible by 3.
Yeah, absolutely right. So we add these 7, 4, 2, 9, all these digits, and if that is divisible by 3, then it would be divisible by. So then this number would be divisible by 3. So that is one such rule, right? And then 5 is easy, right? 4 we don't bother because when it is divisible by 2, so that would be divisible by 4. And 7 and 11. Oh, I have forgotten about 7 and 11, but we can check. So these things that we have to remember, right? So let us quickly, you guys do this question and tell me what is the factorization of this. For starters, let us start with a very simple question. क्या है? One moment, give me 1 minute. Yes, guys. And let me tell you one thing. Whenever in the exam you get these kind of questions, so you skip these kind of questions, right? Because finding out the factor would be troublesome, right? We have to check with 17, 21, and 37 and all that. So that would take a lot of time, right? So whenever you guys get these kind of questions, skip these, move on to the next ones, and then whenever you have completed all your questions, then get back to this. So this is just to eat your time, right? Don't get distracted with these kind of questions. So they will eat a lot of time, right? Because when we try to find out the factors, then it will take our time. Whenever you guys get these kind of questions, skip that and do all the rest of the questions, then get back to this. Yeah, did you guys get the factors? One is direct, yeah, five, that is there. But after five, I don't also, yeah, I also do. And you guys are still dividing, right?
Sir, I got it. Sir,
Got it.
5 into 7 into 11 into 13.
Yeah, so these are the culprits, right? And always remember, don't don't look the 8 table, don't look the 9 table, don't look at the whatever, because we have to only find out the prime factorization, right? So the prime factors are only, let's say, 2 and 3 and 5 and 7 and 11, 13, 17, and then 19 and so on. 20, oh, 21 is also not there.
Yes, sir,
These
same. I got the same.
same number, right? Shaima, did you get the answer?
Yes, sir.
Good. And this one would be more troublesome to find out, right? So whenever, that is what I wanted to just tell you guys, whenever you guys get these numbers, keep these for a while and then return back, right? But don't forget to calculate these. So skip these. Okay, so let's do this fourth one, which is important one. Do this, okay, but before that, let us, yeah, quickly do this eighth one. Tell me the third and this part, and then we'll do this question, and then we'll move on to the next chapter. So quickly do these questions. Third one. This chapter is the easiest of them all, right? This one is the easiest. And side by side, while we are together doing this revision, you guys also, right, side by side, do your kind of revisions, because you guys know yourself very well other than anybody, right? Make your timetable properly and utilize your time very carefully. And now only do the sample papers, right? Every day, let's, yeah, guys, just make a habit that every day you solve one sample.
I got the LCM as 1800 and
Yes,
HCF 1.
LCM is 1 and 0.
180000.
Oh, this much LCM. And HCF
1.
1.
So same, I also got the same.
Yeah,
Sir, I got the same answer.
right. And yeah, it is not needed to multiply this number, right? So whatever factors you are getting, whatever 2, 3, that is also correct, right? So let's say that number is large, then don't multiply. It will take a lot of time, right? Okay, do this fourth one quickly. Good. See, Amira, you have improved a lot, right? So, but work on that calculation part, right?
Yes, sir.
Don't eat steps, right? You only need to follow each and every steps properly. Yeah, and when you get a hang out of it, then you can leave some steps that you already, right? But yeah, I guess you try to leave some steps and then you do this calculation. There, do that, right? Do this fourth one, and then we'll do the seventh one, and then we'll get back to, or then we'll go to the second chapter. What I can do is that, so you guys have some trouble in the first or 1 mark question, right?
So I'm getting 222338.
So you have multiplied that
Sir, I
also.
got the same answer.
22338. So you guys have multiplied that.
Yes, sir.
Okay, good. Yours calculation is faster than mine, right? Okay, if everybody is having the same answer, then please do the 7, right? As you guys saw when I was talking to Amar, that we did this question. Quickly do this question and then we will move on.
So can you scroll down?
Oh, yeah. The question is that we have to find out that when they will meet again, right? They are moving in a circle, both the guys, and then they start from the same point and then they have to come to the same.
Sir, after 36 minutes.
Yes, sir. Same.
36. 36. Right. Everybody got 36? Right. So we have a circle. Thank you. Draw this thing. So we have a circle. And let's say this is Ravi. Right. And let's say she is, so she is, so she is Sonia. So both start from this point. Right. And so Ravi in 12 minutes, Ravi completes one full rotation. So Ravi starts in 12 minutes. He comes at this exact position. But Sonia, what about Sonia? So Sonia is still, because Sonia takes 18 minutes. So in 12 minutes, right? In 12 minutes, Ravi is at this exact same position. But Sonia is in here somewhere at here, right? In 12 minutes. In 18 minutes, Sonia is at this position, right? In 18 minutes. But Ravi has crossed this path, so both will not meet at this point, right? So then we have to, as you guys have got 36 minutes, So in 36 minutes, Sonia will complete 2 circles and Ravi will complete 3 circles, right? Both will be at the same location in 36 minutes. That was the question, right? Once Abir told us that whenever you have common, we want to calculate the common thing, right? Then we calculate LCM. Whenever we arrange, then we calculate LCM, right? So arranging those columns, arranging those groups, arranging all those. Whenever you guys get arrangement, then you calculate HCF. Whenever you want to calculate the common time, common whatever thing, then you calculate HCF. Right? So this is it. Okay, so this next part is about the roots, and we have done that already, right? So let's say 5 and these things. These things you can do. Now let us move on to the next part, right? The next chapter is polynomials, right? So in polynomials, what were those things that we understood? So first we talked about number of terms, right? So we had monomial, so it had one term, and then we had binomial, it had 2 terms, and then we had trinomial, 3 terms, and then quadrinomial, 4 terms, and so on. So all these are called polynomials on the basis of number of terms, right? And so on. The pentanomial, hexanomial, and all these things. Right? So this was the definition based on the number of terms. And we had 2 important things about the polynomial. So one was that the polynomials can't have negative powers or power on the variable. Right. So if we get some terms like this, let's say 1 by x cubed plus x squared plus 5. So this is not a polynomial because the power of x is in here minus, right? This is not a polynomial, right? So this is one criteria, and the second criteria was that the polynomial can't have fractional power on the way, right? So for example, we have some terms which is root x plus 5, right? So this is not a polynomial. Why? Because it has power fixed to the power half. Because root is power half, right? Root is power half. Cube root is power 1 by 3 and so on, right? All these things that we have to. So whenever we have these kind of terms, then it is not a polynomial. Okay, so this is there, and let me, yeah, I have so many times I have asked this question. So you guys tell me that is this a polynomial? Is this a polynomial? Yeah, is this a polynomial?
Yes, sir.
Yeah. So Aisha is saying yes.
Yes, sir.
Shaima and Amina, what about you?
Yes, sir.
Good. So I wanted to trick you guys, but you guys have become smart enough, right? So yeah, good everyone. Yes, absolutely correct. But because this is looking like a negative power, but when it is multiplied with this term, so this would become x square, right? So this would be the simplified, and this is a polynomial. Yes, good. Okay, so this was the thing that we talked about or we learned in this part. And then after that, we talked about the degree of the polynomial. Degree of the polynomial. So let's say you are given, it is already given that that is a polynomial, right? So then this degree of the polynomial is the highest power on the degree, right? So let's say px is x cubed 3x cubed plus 4x squared plus root x. So what is the degree of this polynomial? Yes. What is the degree of this polynomial? Yes, guys. What is the degree of this polynomial?
The degree is 3, but not polynomial.
Yes. Degree?
The degree is 3, but it's not a polynomial.
Yeah. So
Sir,
yes, guys.
9.
9. Okay. No, no, no. So both of
Uh,
yeah, I
no,
wanted to.
sir.
So now, so now you guys have yes. So firstly, this is not a polynomial, right? We talk about the degree. We first, when it is a polynomial, then after that we talk about the degree, right? First, we have to find whether it is a polynomial or not. So this is not a polynomial. So we can't talk about the degree, right? This is not a polynomial.
Yes, sir. I
Yeah.
squared it.
Yeah. So yeah. So if we assume that this is some equation, right? If we had this equation, then we can write it by squaring it. Then we can write the polynomial, right? But this is not an equation, right? This is some. There is nothing in the right hand side, right? Yeah.
Yes, sir.
Firstly, yes, yes. Now you guys got caught in this trick, right? Okay. So now let us write the degree, right? So let's say we have a polynomial on the basis of degree, right? So if we have degree 1, so that is a linear polynomial. And then if we have degree 2, so that is quadratic. And then we have this 3, this is the cube. So on the basis of degree of the polynomial, these are the definitions or these are the types of polynomial, right? And we'll see in the third chapter that we have ax plus by plus c. So that is the linear polynomial, or this is the equation. So we have linear polynomial x y. So there are two variables. So yeah, we'll talk about them. So these are on the basis of degree. And then we have zeros of the polynomial. So what we do is that we put Px equals to 0. Then the value of x for which Px is 0. That is called, those values are called solution of Px, solution roots, or zeros, whatever you want to call them, so of the polynomial. So these are the thing about the polynomials, right? And then we have this graphical representation of zeros, graphical representation. So let's say we have this px, and this is x, this is some polynomial. So these would be the zeros, right? Because at this point, px would be 0. Y-axis is 0 at this point. So these are the zeros. Okay, so yeah, we'll continue from here in the next class. But before we do that, you guys please talk, right? The parts, right? Because I will write in the single thing so that you guys have all the notes with you so that you can quickly revise whatever we have done, right? Stop at here, and in next class we'll talk about polynomials, and if we may start the linear equation and the important questions of that. Yeah, whenever you guys want me to scroll it down, please tell me.
Noted, sir.
Noted.
Sir, can the power be 0?
Yes, what would
For
be
the polynomial, the power can be 0.
terms?
No, sir, the power.
Power, yeah. Obviously, let's say you have 5, right? This is one term, right? Px is 5. This is a constant volume, right? So, yeah. In here, power is what? X to the power 0. Power can be.
Noted, sir.
Noted as well. So then we down.
Noted, sir.
Oh, already. And yeah, all these things you guys have already done, but we are just recapping quickly. And whenever you guys have noted that,
Done, sir.